Welcome to the Game Design and Development track. I do not know if you can actually see me now because as usual in Zoom, I cannot see me, but hi, I'm Martin. I will have the honor of moderating this track, and since we are behind, I will just try to get to the first paper as quick as possible, which is a video presentation as far as I know, and called Legacy of Code, Studying How Amateur Game Developers Use Graphic Adventure Creator. Can the person in video charge kick it off, please?
Yes, I will load it up.
Awesome.
And I also want to say that this paper is also one of our best paper nominees.
Yes, and it is by John Aycock and Katie Bittner, sorry.
How did game programmers use early game development tools? How does this fit into the bigger picture of how humans use tools and technology? If we look at the archaeological record, we find evidence of games in the form of material culture, or what we call artifacts. Examples include icosahedrons, more commonly known as D20s or 20-sided dies, which dates between the 2nd century BC and 4th century AD. We also find board games like the Royal Game of Ur, which was played in Mesopotamia in the 3rd millennium BC. Today we find similar artifacts associated with our games and gaming. Our D20s and board games, while found in a bewildering display of colors, shapes, and sizes, still echo attributes of their earliest ancestors. Archaeologists use what we know about games and the material culture of gaming today and how humans play games to look for and to interpret what we find in archaeological sites and to reconstruct what humans were doing in the past. However, this paper isn't about the antiquity of games. It's not about the archaeological record of games either. Instead, what it is about is how we can use methods from computer science and interpretive theoretical frameworks from archaeology to examine the games of our more recent past.
I want to take you back to the 1980s. This was peak text adventure game all through this decade. And so we had all these text adventure games like Zork. As early as 1980, we had these games illustrated like Mystery House. And at the same time, we had these computers that were being sold into people's homes, and they had the basic programming language typically built into them. So as soon as you powered on the computer, you had a programming language. Now, in the early 1980s, there were all these books talking about how you at home could create your own text adventure games. And when you take this with some of the construction sets, tools at the time, like Pinball Construction Set, what you end up with is this convergence of influences leading to this, GAC, the Graphic Adventure Creator. Okay, it doesn't actually look like that much, but wait until you see the main menu, which also admittedly does not look like all that much. So GAC was a menu-driven program, as were many back in the 1980s. And what GAC gave you was a domain-specific language precisely tailored to the task of creating your own text adventure games. And optionally, what you could do is you could add graphics into them to be displayed when the game was played. From the programmer's point of view, what you would be presented with when you're editing the code in this domain-specific language was you would be given a line at a time to work with. And in fact, line-based editing was not unusual for the time. But let's see what these games looked like. This is King's Ransom. It is a game that is packaged in with Graphic Adventure Creator. We'll press the key to start. Really, all the game's narrative is text-based, and the pictures are simply illustrative. I am at the bank of a turbulent stream. I can see an old oil lamp. I will get the lamp, and I will move E for east. It's dark. I can't see. I had better use that lamp, so I'll say lamp on, and it lights up, showing me the interior of a cave. I have choices as to path, whether I want to move to the south or to the east. I will move to the east, and when I do, what I see is a small snake is sleeping in its favorite, and I'm dead. For our work, we're going to be looking at the version of GAC that ran on the ZX Spectrum. Now, the Spectrum was a hugely popular computer in the UK at the time. And from this picture, it looks enormous. But in actual fact, the ZX Spectrum was pretty tiny. And if you're unfamiliar with computers from this era, this is the entire computer. This is not just the keyboard. The idea is that you would have taken this, you would have plugged it into your home television, you would have plugged your home cassette player into it to load and save programs, and all these things taken together, this was the computer that you used. And the mention of cassette tapes brings me to the fact that we have a corpus of all these GAC games for the ZX Spectrum, and they're originally on cassette tape. So in total, 132 games, but because cassette tapes were limited in how much they could store, if you had a game longer than that, you would have to flip it over to the other side of the tape. And effectively, for our analysis, as soon as you do that, that becomes a separate game. Part 2 is a separate game. And so all told, we have 154 game images, almost all in English, and they span the years 1986 to 2011, although the median's 1988, so basically there was a big glut of GAC activity right when it came out, and it tailed off after that point. So what we have is we have a system that we built, and what that allows us to do is rip the data out of each of these game images and store it in a form where we can feed it into our game analysis framework. And what we can do with our framework is we can plug in different analyses, and these can be static analyses, so just looking at the code and analyzing it without running it. But also we have the ability to do dynamic analyses where the game code is running in a sense. And the way that we do that is we feed it to a sandbox game interpreter we have. So we can look at our games a whole bunch of different ways, and we can start asking and answering these questions across our entire corpus. For example, how did GAC programmers use the game elements? Well, as you might expect, being text adventure games, these games tended to be very text heavy for both that and the reason that pictures would simply have taken up more space. So what we see is these are text-heavy games, but even so, there wasn't an awful lot of text, especially if you compare these to professionally produced games. So if we were to look at the Zork series by Infocom, for instance, they had an average of rooms and of objects per game, which was much, much higher than what we're seeing in our GAC corpus. What we can also do with our analysis framework is we can look for trends over time. And while many of these games did not have a lot of pictures, most of them did have at least some token pictures. And what we can do is we can see and view our corpus over a long period of time and see how programmers were using this. We can also look at the code that these programmers wrote. So the GAC code in this domain-specific language is broken into 3 parts. There was high-priority stuff, which is executed first. There was low-priority stuff, which is executed last. And then there were local conditions that were attached to a specific room. What programmers were encouraged to do is they were encouraged to write condition action code. So really, if-then statements. If verb equals eat and noun equals food, then eat food. And as a reflection of this, we see that the most used operations statically were and to combine these conditions together and the if operation. We can also look at how careful GAC programmers were when they wrote this code. Now, some of the oddities we see in the code admittedly might be quite readily chalked up to the simplistic interface, so seeing only a line of code at the time. GAC editing tended to be a little bit buggy, but something like writing text was a lot more under the control of the programmer. And when we took all the English game images, we had 124 of them, and ran them through a spell checker, what we found is that only 11 were free of spelling errors. Did these programmers follow the instructions that they were given? Not so much. What we found is that programmers were using constructs in ways that were not prescribed by the manuals. And when they were told how to do something in the programming manuals, they tended not necessarily to follow those instructions. But what does all this tell us about how programmers worked and how they used GAC?
To do this, we've chosen to define GAC as tool. When archaeologists study tools in the real world, or as what we jokingly refer to as meat space, we begin by just defining the tool's attributes. And attributes are simply just the traits of that tool, right? This could be anything from its color to its shape, its size. Really, it's up to the archaeologist to determine and define what these attributes are. We use attributes because they allow us to identify, characterize, and describe the tools, but also allow us to make interpretations around how the tool was constructed, why a tool was selected for use, and how the tool was used in its broader technological context. Now, the key attribute of GAC as tool is clearly its code. It is through this code that built-in functions, operations, and variables in the form of markers and counters are provided to the user, right? So the user uses the code to design and build their games. But the user is also responsible for keying in much of the content of the product, right, of the game. The user has agency. They can make decisions and have choices around what code to use, which variables, and also vocabulary to use in building their game. In terms of vocabulary, overall, we see very low diversity, and this also applies to the number of markers and counters that are used in the game. The simplest explanation for this is that it's likely linked to an economy of resource consumption, notably time and effort costs. The space and difficulty required to incorporate pictures logically into games, and also the hard constraints imposed by the Spectrum's memory, is probably why the majority of games are text-based rather than take advantage of GAC's capacity to incorporate images into the games. But what about the low diversity of vocabulary present across the corpus of games? Even though games themes vary from lawnmower simulators to fantasy favorites like Frankenstein and Harry Potter, we're not seeing a lot of different kinds of words being used in construction of these games. Some choices that our agents, our users of GAC are making are kind of confusing as well, right? If we just look at them on the surface, why do swear words, for example, appear at the same frequency as the directional movement commands, such as southwest or northwest, right? What is influencing these decisions around vocabulary, around markers, around counters, indeed, even how to initialize the game that we see the users making? So to answer these questions, we can also look at the context of game design. This includes all of the knowledge and information that the user brings with them when they utilize the tool or GAC as tool, but also all of the influences on how they choose to use their knowledge and their skills and the tool itself. And this kind of broader context and these influences include things like manuals, advertisements, but also things like the GAC reviews and articles about GAC and its potential utility. This archaeological perspective enhances our understanding of GAC as tool, and further, it situates game development explicitly as the human-technology interaction it is. Thank you.
All right, thank you. It is so weird to not have an applause after a presentation. We have maybe 1 minute for questions, but there is a chat going on. If anyone wants to ask a question live, please raise your hand or stay forever silent. Looks like the chat will take care of it. Otherwise, there is also the Discord, of course. Clap, clap, clap is good. Yes, thanks, Jose.
So Martin, there is a comment about some of the authors of GAC content being kids, and yeah, in the paper we had some examples where there were actually instances captured in some of the games where there would be Easter egg messages or things saying how old an author was.
Do you want to answer any other questions quickly that came up, or topics, comment on topics that came up in the chat?
What's the weirdest, most interesting GAC game you came across? Oh, wow. With well over 100, they kind of blend together after a while, let me tell you. I remember there was one in particular where you were stuck on a toilet and you had to get your way out of the bathroom, and that was the whole premise of the game. And for some reason, that one was just bizarre and stuck in my head. But Katie and I will be hanging out on the Discord chat afterwards if there's any further questions, certainly.
Perfect. Thank you very much for your presentation, Sean and Katie. Next up is a fantastic topic, failing, a diagnostic taxonomy of failure in video games by Batu and Adam. As far as I know, one of you should be at least here in the chat.
Yes.
Yes,
here
Batu
I
is
am.
here. Fantastic. And you
Should I
unmuted yourself, so I can just hand over to you.
Sweet. Let's kick it off. Okay. Okay. Hello, everyone. My name is Batu, and today I'll be presenting a diagnostic taxonomy of failure. This paper is from myself and my advisor, Adam Smith, and we're from UC Santa Cruz from the Design Reasoning Lab. Can you see the top right of my video? Let me hide it. Okay. So I wanted to start by talking about where this idea came from. I think it was after a lunch, and I was thinking what the game designer actually did. And turns out that I've lost horribly whatever game I was playing, and I was pretty upset. So I came up with the grand declaration and said, a game designer's job is to minimize failures. After thinking for more than 7 seconds, I've realized that really isn't the case. These 4 games that you're seeing on screen, Getting Over It, Dark Souls, Rogue, Darkest Dungeon, these games have failure as a core component, and Rogue and roguelikes have failure as a core component as a whole genre. So it seems to me that, and it seems to probably to many other people, that failure is not, a game designer's job is not to minimize failures. And even in games that are not explicitly brutal, like Mario, failure is a core component as well. You play Mario, you jump, you die, and you try again. So yes, failure is important. And yet, and a game designer's job is not to minimize failures. So there's something else there. But also, not all failures are good, right? Sometimes failure makes you feel like this. It's very annoying. You stop playing the game. It doesn't leave you with a good taste. The game just rejects you. And maybe more importantly, sometimes failure arises from a mismatch of the abilities of the player, capabilities of the player in the game. For example, if a player has color blindness and they cannot differentiate the enemies who are in red and allies who are in green from one another, and as such fail, that is definitely not a core component of any game. So then some failures are good, it seems like. Which ones and how do we tell? So these are the core questions that we wanted to answer in a diagnostic taxonomy of failure. So before we get into the taxonomy of failure, let's talk a little bit about Jenga. Jenga is a game where you don't necessarily have to play it in the Arctics, but this is the photo that came up. You build blocks, you draw certain blocks, and whoever collapses the grand tower is the loser. So imagine you're playing Jenga and you drop the piece. That is a physical manipulation failure, right? Yeah, like you're picking something up physically and you're failing in manipulating the object correctly. The tower collapses. This is not a problem. It is not a problem in the sense that it is not a design problem. That type of failure isn't necessarily a design flaw. The reason why that is the case is because the failure supports the core gameplay loop. And with the core gameplay loop, I'm not referring to the update loop or programmatic loop, but rather the actions that the player repeatedly takes over the lifespan of the game. So let's look at chess. Let's say you're playing chess, but it's a weird and kind of alien chessboard, and you drop the piece. Once again, it's a physical manipulation failure. It's literally the same. You picked up a piece, you dropped it, similar to Jenga. But in this case, it is a problem. You really don't want to be dropping pieces in chess. So this is a failure and this is a problem because the failure does not support the core gameplay loop. Chess isn't about moving pieces gracefully, but it's about moving them wherever you want to and planning where to move. Right, so there's the exact same type of failure. It is a physical manipulation failure. But in Jenga, it is an in-loop failure. It is not a problem. And in chess, it is an out-of-loop failure. It is a design fault of the chess pieces in this case. So I define in-loop failures as failures that are expected to happen in the game. And these push forward the play experience in most cases. On the other hand, out-of-loop failures are failures that are not expected to happen in the game loop and are expected to be minimized. You can also think about these as in-loop challenges and out-of-loop challenges. A challenge while playing chess shouldn't be moving the pieces from point A to point B, but it should be about where to move them, right? But when it comes to Jenga, the ability to actually move is an interesting challenge. So we talked about physical manipulation failures, and you can come up with many, many more failures. Failure in taking cover, failure in jumping, pressing the wrong button, so on and so forth. And it kind of became overwhelming. So what we decided to do is we decided to collapse these different types of failures into classes of failures. And the way we went about doing that is we observed and interrogated how one plays a game. And our play model, let's say, was informed by Don Norman's model of interaction and some other earlier literature. So what we claim is that the player has a mental model of a game. Using that mental model, the player makes a plan. Let's say we're playing Super Mario. I know that our character is going to go to the right and there's a Goomba. I'm going to say, I'm going to jump on the Goomba and then clear the gap. That's my plan. After having made the plan though, I need to be able to execute the plan. And this is simply pressing the buttons that actually maps to the plan. So going back to the mental model, after my results are in, after I press the buttons and see whatever's happening, I update my mental model. So what is actually my mental model? We separate it into two parts. One is discovering mechanics, effectively meaning what can you do in the game? What are the affordances, mechanics, systems? That is the player's knowledge of the whole things that they can do, the span of things that they can do, and also setting goals. So what should you do in the games? In combining what you can do and what you should do, we say the player has a mental model. So this is an iterative loop. The player has a mental model, plans, executes, updates the model. But in order to engage in this loop, there are two preliminary steps. First, the player actually has to be able to engage with the digital system, right? So they need to know what the buttons and gestures there are to engage with the game. And they also have to be able to physically enact those actions. And also, the other side of that, the player has to understand what the game is displaying, visually, orally, tactily, or language-wise, what have you. So we collapse all these chaos of different types of failure instances into 6 different need classes. And these 6 represent different places a player can fail while playing a game. So let's go back to our physical manipulation failure. It is an execution failure, right? You decide to pick a piece and then you failed in moving that piece. So in Jenga, execution is an in-loop failure class. What I mean by that is if while playing Jenga, you have a physical manipulation failure, you drop the piece, that's okay. That is supported by the game. Whereas in chess, execution is an auto-clue failure class. You really shouldn't be dropping chess pieces, ideally. Although that would be an interesting variant. Let's have AIs play that. So these are the ideas that we want to carry forward. And they're just going a little bit deeper into these. Encoding input, what physical actions will allow me to act in the game? Decoding output, can I parse the feedback of the game? Discovering mechanics, do I know what I can do in the game? Whereas goals refer to, do I know what I should accomplish in the game? Planning, what steps should I take to accomplish my goal, that I know or not? And execution, what should I do? So the specifics and examples of each of these classes are detailed in the paper. I'm not going to go too much deeper. So let's take an example. Original Super Mario Bros. It is the first one. I claim that these are the in-loop and out-of-loop failure classes for Super Mario Bros. And the interesting thing is we can debate and discuss and reach different conclusions about these. Well, let me run you through about my internal process. So in Super Mario Bros., let's start with setting goals. You really should know that going to the right is the right way to go. The game doesn't necessarily give you a lot of space to explore with different goals, and the game teaches you or attempts to teach you going right is the right move very early on. Similar to discovering mechanics. There isn't a big space of mechanics in the original Marios. You jump, you grow, you hit on Goombas, and if you, for example, fail because you don't know that you can break blocks, or you don't know that you can hit on the head of the Goomba and you get stuck and cannot progress over a long span of time, that's a problem. Whereas planning and execution are in-loop failures, right? If fun of playing Super Mario is like planning which route you're going to take. You're running, I'm going to jump on that Goomba and do a somersault. Yes, a somersault, and then actually being able to execute those button presses. So those are, if you fail in clearing a gap and you're just a little bit off because you pressed the button a little bit early or late, yeah, that's okay. And the other two, decoding output and encoding input, if you cannot see the screen or if you don't know the buttons and you're failing because of that, that's pretty bad. Let's take another example, Where's Waldo? So for those who don't know, Where's Waldo is a game where you're trying to find Waldo in pictures similar to this. In this case, Waldo is over there, that little guy over there. And imagine we're playing the digital version of Where's Waldo. So in Where's Waldo, the difficulty or the challenge comes in decoding output. The only reason why you should fail in this game, in loop-wise, is if you cannot spot where Waldo is, and you can't necessarily find it in the whole group. Imagine in the digital version of the game, you see where Waldo is, so you didn't fail in decoding the output, but you somehow messed up clicking on Waldo and showing your intention to the game, and you failed because of that. That would be annoying. But if you couldn't find Waldo by matching decoding the output, that would be okay. So this is the taxonomy, but we say a diagnostic taxonomy. So how can this be useful? Why am I talking to you about this? And why do I hope that you actually use this taxonomy? These are not experimentally validated. These are how I use this taxonomy myself in my own practice. First, as a game designer, it is helpful in ideation, right? You can take a game, let's say a random first-person shooter, and say like, okay, what would it look like if execution wasn't an in-loop failure? If execution wasn't necessarily a challenge that the players have to face, then you get super hot, or a version of it, where time stops when you stop, right? So aiming is planning, where to move is much more important. It's actually useful as a communication technique, right? If you're working with a large team, you can say, these are our in-loop challenges, then everyone knows what the direction of the game is. And you can evaluate your future design choices through that lens as well, in addition to other design choices that you have, or design lenses you have. And finally, it is, in my opinion, very effective as a playtest analysis tool. You annotate the failures of your player while they're playing and see if they're failing in an out-of-loop failure case. And if that is the case, you tweak the game to remove those. And there's an extended taxonomy of failure that we talk about in the paper that specializes the taxonomy for the given game that you're working on. I also work as an AI researcher, and I use the taxonomy to identify projects. The thing I do is I basically look at, I make AI-driven assistance methods, and the way I use this taxonomy of failures, I look at a game and say, okay, can I come up with an AI technique that specifically targets discovering mechanics failure class? If that is an out-of-loop failure, and if we don't want players to fail, then maybe we can support the player specifically of that. And finally, I claim that it is helpful as a game analysis tool. It is another way to cluster games and analyze games, in that usually we cluster games over genres, but now we can cluster games over failure types. And I find it useful as a pedagogical tool, asking my students to go over the games they made and analyze them through this lens. My students seem to like it. So in conclusion, some failures are good. Which ones? In-loop failures are good, out-of-loop failures are bad. And how do we tell? We use the diagnostic taxonomy of failure. Thank you very much, and enjoy failing. And I'm open for your questions. Let's open chat.
Thank you very much. If anyone wants a question or wants to ask a question, I should be able to see it here. Nice talk. Or just post it in the chat. Henrik, please just unmute yourself and ask.
Yeah, hi. So thank you for a really interesting talk. I think this was a really refreshing way of looking at challenge, if nothing else. Have you heard of Linderoth's, I guess it's the typology of challenges?
Not necessarily, no, I can't recall.
Right. So this is more of a comment than it is an actual question, I guess. But take a look at that, because I think that would be really useful for you to, if you're looking to validate this scientifically, you could probably use that as some kind of theoretical framework for this.
Would you mind sending the name of the author in chat? I couldn't.
Absolutely. I'll do that.
Thank you very much.
All right. That was it. Thank you.
Any other questions I can take?
There is one from Jose in the chat. How do you think this taxonomy maps to goals in games?
Yeah, that's a really good question. So I kind of waved my hands over and didn't necessarily define what a goal is and didn't necessarily define what a failure is, because it's difficult to define failure in absence of a goal. So in the paper, we basically say this taxonomy functions as towards the goal suggested by the game in order to simplify things. But you can basically categorize it differently. So I talked about Super Mario Bros. If you're playing it as a speedrunner, your goal is totally different. And suddenly discovering mechanics becomes an in-loop failure. Why? Because you're trying to push the boundaries of the game and you're trying to actually extract really interesting nuances that really wasn't in the original way of playing. So how does it relate to the goals? It is somewhat defined by the goal that you initially assume. Yeah.
Okay, thank you very much. I think we have to head on to the next paper. I was also super inspired by this. It was like both papers were super excellent, but I'm just writing about something that also relates to yours, and I'm thinking like, oh my God, there are so many links, so that always makes me very happy. But our next paper, goodbye Batu, thank you. Our next paper is Scheherazade's Tavern, a prototype for deeper NPC interactions. Presented with a video, but Elizabeth and Rehav are supposedly in the Zoom, so we can make a Q&A afterwards. But first, a video.
Hello, everyone. Thank you for coming to this talk. My name is Rehav Jamaz. And on behalf of my co-authors, I'm here to present Scheherazade's Tavern, a prototype for deeper NPC interactions. NPCs play a vital role in many games today. They contribute to the story and lore, are fun to interact with, and aid in immersing the player in the game's world. To that end, we wanted to study player-to-NPC interactions. As for our goal, we hope that by combining natural language, social simulation, and knowledge modeling, we can create characters with a sense of depth. We aim to do that by building a prototype, expanding upon existing techniques to allow for a more in-depth, varied interaction. What do we mean by depth? Our notion of depth extends from character believability. We wanted to create characters that have a sense of a coherent personality, an internal life, and a consistent backstory. Our prototype attempts to support depth by, firstly, allowing the player to interact with the NPC through a natural language interface. As natural language invites the player to express themselves and supports the player's sense of exploration. Secondly, by allowing the NPC agency in the conversation, we hope players perceive NPCs as entities with lives. We hope to achieve this through ensemble. And lastly, via knowledge modeling, by allowing the NPC to know facts about the world they exist in and comment on them. What's our prototype? In our prototype, players take on the role of a tavern keeper in a small town. Players get to interact with one of our patrons, an NPC named Marco, via text and the use of natural language, where the NPC can initiate or respond to conversation via social modeling using ensemble. Both the NPC and the player can reference and from their own knowledge bases. As mentioned earlier, our prototype includes 3 different parts. The natural language aspect of our prototype uses an off-the-shelf tool called DriveScript. We use DriveScript as both an intermediary point in the system, feeding to and from the social simulation engine, and as a standalone chatbot. As for the social modeling aspect, we use Ensemble for the social simulation engine. Ensemble is a successor to SIF, a social simulation system used in the experimental game Prom Week. It uses rules to compute the utilities of character actions based on the current social state. Through Ensemble, our NPCs are able to take actions according to their own volitions. As mentioned earlier, both the player and the NPC can reference their own knowledge bases, with each character possessing a unique subset of facts in the world that they can bring up in conversation. Previous work has also extended SIF with knowledge modeling, like the paper From Caveman to Gentleman. We'd like to present an overview of the system with an example. The player might enter a text such as, "How is your family?" It gets parsed with RiveScript. However, instead of the bot directly responding to the player, it outputs actions to the social simulation system. For example, "How is your family" is mapped to the ensemble action, "Ask about family." Depending on the action and state, it can have success or failure states. In this case, "Ask about family" is successful. It then grabs a fact from the knowledge base about his daughter Alicia, like how she recently took over the town's clinic. If this were the case, "Ask about family" response, "Alicia took over the clinic," would get parsed through RiveScript and mapped to, "Have you heard? Alicia took over the clinic." We have 3 different RiveScript bot cases. The first case is traditional. The first case is traditional stateless mapping, where RiveScript translates input to output. For example, if the user mentions anything with the keyword Jasper, it leads to an output of, "Jasper, what was I saying again?" The second RiveScript bot is used for intent recognition, translating from user input into ensemble actions. For example, if the user text mentions anything in relation to the string "family" or "Alicia," it would map it to the ensemble action, "Ask about family," as seen in the earlier example. Lastly, it parses it from ensemble action, the internal simulation model, combined with the knowledge-based facts where applicable, back to natural language. Its inputs in this case are structured text representing the action the NPC wishes to take, with the associated data selected by the ensemble engine and knowledge base, and expanding it out to a natural language utterance, which is then displayed to the player. For example, "Ask about family" response, added with the knowledge base fact, with the subject Alicia, action took over, object clinic, would get parsed to, "Have you heard? Alicia took over the clinic." Marco can also direct the conversation by taking an ensemble action. Due to his internal state, one of the things he most likes to do is complain to the player. He might at this point decide to initiate a complaint action. In this case, ensemble would execute the complaint action, which has no success or failure states. The complaint action would be passed to the knowledge base as a fact is needed to fill in what he complains about. The knowledge base would pick a fact that has a negative opinion, represented by a negative numerical value. It might pick "Alicia is dating Jasper." Finally, it gets parsed into, "I am sad about Alicia dating Jasper." Lastly, if no intent is recognized, the quick response bot provides a traditional chatbot response. For example, if the user enters, "Who is Zelda?" it gets parsed to, "Zelda, that's right, she's the town butcher." As for our methodology, we did a small exploratory study with 9 participants. We asked them to interact with the NPC for a few moments and think aloud. We later asked them questions tailored to their engagement, interest, agency, as seen from the NPC's ability to lead conversation through ensemble, and usability. We found that the majority of our players recalled memorable moments in the conversation, and they recalled facts about different characters in the world, as told by our NPC Marco. Most of our players were also interested in talking with Marco. They were also interested in gaining background information about the characters or the world. The majority of our players found the interaction mechanic fairly intuitive, where 7 out of 9 users felt that the interaction mechanic was intuitive or that it enhanced the experience. As for NPC agency, as represented by the NPC's ability to direct conversation via ensemble, had mixed results. 3 users found that Marco's action had a negative impact, leading them out of conversation or a topic area they still wished to explore. But 4 users recognized Marco's attempts at conversation as successful. As for our key findings, we found that the interaction encouraged players to explore character backstories, where players learned about the world through gossip. We also noted how players managed to recall memorable moments. It was also interesting to see players assemble information from characters to form a story or even roleplay a character. Open dialogue systems tend to introduce an authoring problems, where the openness of the input requires a large amount of authoring. Our players did experience limitations due to limited authoring. In some cases, however, the authoring limitations and random responses on Marco's behalf occasionally improved the player's perception of both the player character and the NPC personalities. Thank you so much for coming. Thank you so much for listening to the talk. We appreciate this. Have a great rest of your day.
Okay, thank you very much. And are you actually here?
Hi, I'm back.
Yes, hello. Elizabeth is here. Okay, very good. Awesome talk. Do we have questions? Maybe in the chat. Because I have a question actually. I was wondering if the experience of interacting with an NPC is so loose or so undirected. Did you think about, or is that completely out of the question, how that would be combined with, I don't know, fixed points that you actually want people to explore? Like, for example, if you would add this kind of flexibility to a quest giver, at some point, the person has to give you the quest. So how would you mix that?
That's a very interesting question. I don't know if that was necessarily the focus of our project, but it's something I've been thinking about a lot. What is my answer to that? I think part of that comes down to there are certain parts where the player just needs to play along with what story that you're trying to tell. There's some part of the player needs to buy into whatever it is that they're doing. There's some part where the fixed responses, the quick response type things, I think that could be used to, like, okay, if they do this thing, we need to just move along, right? And so I think the system is trying to play with, that there are some things that there's a flexible range of things they might talk about, and there are some things that you want, like, exact scripted things to responses.
So there are 2 questions in the chat now. So the first one is, does the knowledge base allow higher order epistemic reasoning? For example, he knows that, she knows that, and so on.
I don't think our system handles that at this stage. I don't think we got to that.
Okay. And the other question is, are there any special solutions for avoiding repetitions in language patterns?
Not that I can think of off the top of my head. I think we just had carefully written patterns that we were just spent a lot of time.
I mean, that is a solution, isn't it?
Yeah. I mean, yeah, I guess staring at it longer is a solution.
Okay. Reminder again that we have a Discord. If you have further questions, the Discord is still in the first talk, but we will move on to further topics there. Great talk. Thank you very much. And this brings us to the last talk of this session, which is will be presented by Rogelio. And a couple of people are, I've seen Mike's face already, yes, and Jose should also be here. Will be in the chat for questions later. And the title of the talk is Narrative Goals in Games, a novel nexus of story and gameplay. Can a presenter take over, please?
Yes, I'm going to share the screen.
Perfect.
Can I get a confirmation that everyone can see? Okay, cool. All right, so hi everybody. Good morning from Salt Lake City, Utah. So I am Rogelio. I am currently faculty at the University of Utah, and I am presenting on behalf of my co-authors, our work, Narrative Goals and Games. My co-authors, Jose Zagal and Michael Deepus, who should be in chat, and I'm going to task them to answer questions as they come up, and I'll answer questions at the end. Okay, so to start off with a rather incendiary statement, just to get the blood pumping this morning, narratology versus ludology is a false dichotomy, and hopefully I will convince you of this by the end of this talk. But to kind of drive the point home, I am going to be drawing upon Super Mario Brothers, which is great that Batu started us off with this, and kind of hopefully address some of the points that were left unaddressed with his talk and focus really on the goal aspect. So when we think of Super Mario Brothers, what typically comes to mind is something like this. We have the notion of the mechanics, the world, and what rarely comes up, interestingly enough, is literally the last thing that you see when the game ends, which is the following: thank you, Mario, your quest is over. And it's interesting because Princess Toadstool quite literally says the word quest, which is associated with narrative design. And we're going to be unpacking that example throughout the talk. Okay. So starting with this. So this screen is seen when you ultimately finish Mario Brothers. And when we use the word to finish, we mean it as a technical term, as the ultimate goal of the game. And that's the in-game objective or condition that you are expected to meet to succeed at the game. So to finish Super Mario Brothers leads you to this screen. Now, a question that comes to mind is, well, this finish, was it the only kind of goal that exists? Well, no, but we don't have the time to go into this talk and into these different goals in this talk. If you want to know more, this is a paper that was published last year at the Philosophy of Computer Games conference, where we talk about the 3 different kinds of goals, ultimate goals that exist. So to win a game of soccer, for example, to finish Mario Brothers, or to prolong gameplay. And you can look at that paper as to why those specific ultimate goals. Okay, returning. So to finish. Now, one might wonder, well, how do you accomplish that? And if you ask that question to this goal, you get a proximate, what we call imperative goal, which is a closer to gameplay condition that players are expected to meet to ultimately accomplish that top level ultimate goal. Now, what is being depicted here is the removal of Bowser. And it's kind of clunky to talk about it in those terms. You might think of it as defeating Bowser. Ultimately, what this is saying is that to finish Super Mario Brothers, you must remove the Bowser token from gameplay. And then you can recursively ask yourself, well, what does that mean? How do you accomplish that? Well, one way that you can remove the Bowser token is to reach the location that is depicted by what is arguably an axe, so you might think of it as a lever. And this is where it gets tricky, because you can successively decompose these imperative goals, maybe potentially infinitely. But what this is getting at is that there are these imperative goals that exist under this top level ultimate goal. And once again, I'm using the terms remove and reach. And these imperative goals exist amongst the typology of 10 other kinds of imperative goals, which, or 8 other kinds, 10 total, that I don't have time to go into this talk to discuss. But if you want to know more, we actually recently got notice that this paper got accepted to Game Studies. These imperative goals are discussed in more detail, and what, why these and not others is also discussed. Okay, coming back to the example. So this structure of imperative goals under the ultimate goal is what we're calling the ludological hierarchy of goals, or the ludological goal hierarchy. Okay. Back at the top level goal, you can also ask the question, well, what does this mean? Because, when we argue that we're talking about finishing Super Mario Brothers, this has an interpretation that helps you make sense of what that means in the context of this specific game. We argue that to finish Super Mario Brothers means to save the princess. And you can argue for many different reasons why that is. But if you look at the cover box of the game, you kind of get the reason up front. Specifically in this region, do you have what it takes to save the Mushroom Princess, which quite literally suggests that to finish Super Mario Brothers means to save the princess. Okay, returning back to the example. So we have this to finish means to save the princess, but of course, the imperative goals are structured in a hierarchy. And if you apply this kind of reasoning to the narrative side, then you have two hierarchies. Ultimately, the narrative goals themselves are an interpretation of ludological goals. So that's based on what the player thinks and what the game's feedback presents. And it's this mapping that exists between them that's the point of this paper. So this is what we're considering the ludological goal hierarchy mapped onto the narrative goal hierarchy. Let me go back for a second. So I said earlier, to remove the Bowser token, you can kind of more naturally think of it as defeating Bowser. Arguably, to reach that location, you can think about it as destroying the bridge. Now, what's interesting is that the lower level you go, the lower in the hierarchy that you go, the more tenuous these interpretations can become. In fact, there was a discussion amongst the authors of this paper as to whether or not that item that is depicted on the far right of the screen next to Bowser is an axe or a lever, like a literal lever. And in fact, if you think about the animation or the frame rate at which this plays in game, you can kind of imagine that the bridge may not be being destroyed, it could be being retracted, right? And so this feedback is what's contributing to the ambiguity as to whether or not that reach is interpreted as destroying or retracting that bridge. Okay, so we have this parallel goal hierarchy. And remember, on the left-hand side, the ludological side, we asked, what does this mean to get at the lower levels? On the narrative side, you can comparatively ask, why do you want to do this? So you want to destroy the bridge. Why? Because you want to defeat Bowser. Why? Because you want to save the princess. And so you can kind of navigate these hierarchies up and down depending on what side of the hierarchy you're on. Okay, that's it. That's the point of the paper. So narratology versus ludology is a false dichotomy, and hopefully I articulated how these are intrinsically linked. And to kind of be more incendiary, all games tell stories, but some are more told than others. And if you want to know why we think that is, come hear me talk at FDG2020. We have a paper that's called GFI, an approach to narrative design and game research, where we kind of break this apart. It's basically a framework that stands parallel to the MDA framework. Okay, that's the end of the talk. So once again, narrative goals are this kind of bridge between gameplay and story. I talked about the logical side having an ultimate and imperative, the interpretation of them, which is the narrative side, the parallel hierarchies that emerge. And one last thing, a quick announcement. So Michael Debus, who is the third author of this paper, is on the market and is actually the one who spearheaded this giant inquiry into goal space. So if you're looking for someone who's really sharp and looks at games from a very structural perspective and tries to break them apart, Mike's your guy. So be sure to reach out. Okay, that is the end of my talk. So I'm happy to take questions now.
Thank you very much. Shout outs to next talks, job ads. This talk has it all and a controversial topic. Are there any questions by the audience? They are discussing axes versus levers. That is the result.
I have done my job.
Are there any more serious questions?
Yeah, I'm on the Discord as well now, so I'm happy to answer questions at Discord if that's more natural. I can't see the question, so I'll have to.
Okay, no one has an X.
I have blown everyone away with this concept. That's great.
I think it is like it is a little bit of a thankless job to be a last speaker because everyone is a bit tired after an hour of zooming and before that the keynote and just
For
a
sure.
lot.
Yeah.
So I think it's just not the most easiest slot. In any case, so thank you very much for a super nice talk. I look forward to your next talk.
Yes, me too.
And if there are more questions, the Discord is open. And here we will take a short 5-minute break and then continue with the panel at 6:30 already, so in 5 minutes. And thank you all for showing up and coming. I really enjoyed this session a lot. See you here online. Bye, everyone.